Welcome to the notes for writing the equation of a rational function. Today what we're going to attempt to do is write the equation of a rational function by looking at the graph and trying to take into consideration all of the features that we may have. So our equation we're going to be fitting things into is f of x is equal to a, because we're going to have some kind of coefficient to represent the width or the openness of a rational function. And then we may or may not have some asymptotes or some factors, so we have something on top, and then we're going to have, depending again on how many vertical asymptotes we have, some blank spaces here. And then it's possible that we might have some factors that will give us a hole, so we have to kind of factor that in if we do or if we don't. And then the last thing what we're going to have is a value that represents your your horizontal asymptote. It's going to be some kind of shift that we have. Okay, so let's go ahead and look at our first example. It's a little complicated just with this blank shell, but this is kind of our structure. We need to identify some asymptotes, some holes possibly, and you also need to look at the shifts up or down for your horizontal asymptotes. Okay, so looking at our first example here, I'm going to zoom in a little bit. So I want to look at the features that I have. I know that I have a vertical asymptote, I know that I have a horizontal asymptote, and I also know that I have a hole. So we're going to start with that idea of the hole. Looking at my hole, I have an x value of -1. So what that tells me is I need to have a common factor of x plus 1 in my numerator and my denominator, because that is the only way that we would be able to have a hole. In addition to that, I notice that I also have a vertical asymptote here at -2. So we're going to go ahead and put an x plus 2. Oops, that's not x plus 2. Put an x plus 2 in our denominator to represent that vertical asymptote. And then the last thing that I notice, and this is going to be a little bit of an adjustment from what we did with the notes the other day, is I noticed that I have a horizontal asymptote at -1. And to make it a little less complicated for us, what we can do is that's our c value. That's our shift. So I'm going to put a -1 down here. Now the thing that we don't exactly know is our width, or how to adjust how wide a rational function is. So we're going to go ahead and put an a there. And so this is our starting value. Now what we have to do here, and this is similar to what we did with our parabolas, is we need to identify a point, an x and a y value that is on our function that we can use to help us solve for our a value. And you want to generally find something that's pretty easy. So what I identify right away is I have this point here of 1, 0. All right, so I'm going to go ahead and plug in that 1, 0 into my function. So what I'm going to have now is 0 is equal to a times 1 plus 1 over 1 plus 1 times 1 plus 2, and then we have this -1 on the outside. And we can go ahead and work backwards and try and solve for a value here. So I'm going to add 1 to both sides, and I'm going to simplify this to be 2a over 2 times 3, which is 6. And then we're trying to go ahead and solve for a. If I multiply by 6, then we get 6 is equal to 2a, and then if I divide by 2, then we get 3 is equal to a. And now what we can do is I can take my a value, and I can plug it back in into that original equation to get my final answer of f of x is equal to 3 times x plus 1 over x plus 1 times x plus 2, and then -1 on the outside. Okay, let's go ahead and apply this to another example here. Okay, so this is your turn, but we're going to go ahead and work it out together. Again, we want to identify some things that are important to us. We have some asymptotes, we have some holes. So I'm going to go ahead and start with the hole. I notice that I have a hole here at an x value of +1. And so that tells me that I'm going to have an x minus 1 as a common factor on my numerator and denominator, because that's, again, how we get our hole. For my vertical asymptote, I see that I have a vertical asymptote at -2. So in my denominator, I again need another x plus 2. And then I see that I have a horizontal asymptote here at 2, and we're going to put a +2 on the outside to represent that vertical shift up. And then we need a coefficient here, so we're going to put an a here. To solve for our a value, we need to identify a point. We can pick any point that we want. Usually there's some convenient ones that have a 0 involved, so I'm going to go ahead and pick this -1, 0. And again, I'm going to plug that in for our x and our y values, and I forgot to write down f of x equals. Okay, so if I plug that in, then we're going to get 0 is equal to a times -1 minus 1 over -1 minus 1 times -1 plus 2, and then a plus 2 on the outside. Again, we're going to go through some similar steps here. I'm going to go ahead and subtract 2 on both sides, and I'm going to simplify a little bit of what I have. So I have a -2a in the top, and then we have -2 times a +1, which would just be a -2. If I multiply both sides by a -2, then we're going to get positive 4 is equal to, actually, we can just cross cancel this, and we end up getting that -2 is equal to a. All right, so once again, what we're going to do is take that value and we're going to be plugging it in or substituting it in for our a value, which means what we're going to end up having here is, give me 1 second, f of x is equal to -2 times x minus 1 over x minus 1 times x plus 2, and then a plus 2 on the outside. Okay, we have a slightly more challenging one here because we have multiple vertical asymptotes, but same thing. Also, I noticed that they do not have a hole, so I don't have to have that common factor. So let's go ahead and start with our vertical asymptotes. I see that I have a vertical asymptote at a -3 and at a 0. And so what that tells me is I'm going to have some factors of x minus 0 and then x minus a -3 in my denominator. All right, I don't have any other values to plug in for my numerator, so what we're going to just do is put that a value down because, again, we don't have a hole, so there's no factor there. I do have a horizontal asymptote, though. This one's going to be at 0. So technically, we would put a plus 0 on the outside to show that we have that shift, but we can kind of just dismiss that for this example because it's not going to be affecting what we do. All right, so I'm going to go ahead and put f of x is equal to, and then like we had done before, we want to identify a point. Again, find the most convenient point for you. I'm going to go ahead and use this point of 1, 1, plugging it in for my x and my y values, and what we end up getting is 1 is equal to a times 1 plus 3. If I do a little bit of simplifying, we get 1 is equal to a over 4, and if I multiply by 4, then I get 4 is equal to a. Again, as we had done before, we're going to go ahead and plug that in. So I'm going to substitute the 4 for my a, and I have f of x is equal to 4 over x times x plus 3. Okay, we're going to do one more of these your turns together, and then I'm going to have you guys attempt one on your own here. So we, again, are trying to identify as much as we can. I notice right away there are no holes, so once again, we don't have any common things on top and bottom. I do have two vertical asymptotes, though. I have one here at -3 and one here at +2. So we're going to go ahead and write down our factors as x plus 3 and x minus 2. And again, since I don't have a hole, I don't have a factor to put in my numerator, so I'm going to go ahead and put an a on top. I do have a horizontal asymptote, though, at -1, so we're going to put a -1 on the outside, and then we just have f of x is equal to. Again, as always, you're trying to solve for our a value, so we're going to pick a convenient point. I see that I have a 3, 0 that I can use to plug in, and that'll make things kind of simple for us. Okay, so I'm going to get 0 is equal to a over 3 plus 3 times 3 minus 2 minus 1. I'm going to add that 1 over, and then simplify what I have on my denominator. I have a 6 times 1, which is going to be just 6. And conveniently here, all I have to do is multiply both sides by 6, and I get that a is equal to 6. We're going to go ahead and plug that in here. So we have f of x is equal to 6 over x plus 3 times x minus 2 minus 1. All right, for next example, we see we have things a little bit more challenging. What I have here is a slant asymptote, and I'm going to go ahead and try and draw in that equation for us. And it's going to kind of go right through here. And this is going to be a little challenging, but what we want to identify is the equation of this slant asymptote. And I know that means that I have no horizontal asymptote, so I don't have a c value to worry about on the outside. I do have two vertical asymptotes, but first let's focus on this slant asymptote. To find our equation, I'm going to use my points here of 0, 0, and then I'm going to go up 1 and over 3, and that will help me to identify my slope. Again, that y-intercept of 0, and then my slope of 1 over 3 tells me that for my slant asymptote, we're going to have the equation of y is equal to 1/3 x. Technically plus 0, but just 1/3 x. And what that does for us, that helps us to identify another feature of our equation. Okay, so let's go ahead and write down what we do know. We know that we have an a vertical asymptote at -3 and at +3. So we're going to start with those as some factors in our denominator. So we have x plus 3, and then we have x minus 3. And then I know that I don't have a whole, so we're going to go ahead and put an a on top here. And then we have this existence of the slant asymptote. So what we're going to do is we're going to add that to our, we're going to add that whole expression. So instead of adding this value for our vertical shift up and down, we're adding the equation for our slant asymptote, and then we're going to go ahead and put equals f of x. So this is kind of that difference is instead of adding a c value, adding the actual equation for our slant asymptote. And what we're going to do now, same as we had done before, we're going to identify an equation or a point that's kind of convenient, and I like this point of -4 to 0 because that 0 is pretty nice for us. All right, we're going to go ahead and plug in information. I'm going to flip things a little bit, so I have 0 is equal to a over -4 plus 3 times -4 minus 3, and then plus 1/3 times -4. Okay, this is going to require a little bit more simplifying from us. So I have 0 is equal to a over -1 times -7, which is going to be a over 7. And then we're going to have minus 4 over 3. I'm going to go ahead and add the 4/3 over. So then we have 4 over 3 is equal to a over 7. And then at this point, I'm just going to multiply both sides by 7. And end up getting that 28 over 3 is equal to my a value. Okay, so now that I have this 28 over 3, I can go ahead and plug it in. And when we plug it in, it's going to look a little bit different because we have this fraction here. So what I end up getting is f of x is equal to 28, and then we're going to put over 3 because it's our fraction, times x plus 3 times x minus 3. And then we have that plus 1/3 over x. So this would then be the equation of our rational function. All right, so get one more example here. Ooh, that kind of came with this. All right, so we are going to, again, try to identify some slant asymptotes here. And I'm going to go ahead and tell you what it is. It's the equation y equals x. It's kind of difficult to figure this out on your own. So if you had a test or quiz like this, I would give the slant asymptote as well. I'm going to go ahead and plot some points that help me identify that asymptote. Okay, so I know that the equation of my slant asymptote is going to be y is equal to x. The slope is 1 over 1, so we just have that for your slant asymptote. And then when I identify any other features that we have, I notice that we do have a hole, and we have a hole at 0. And so that's going to mean that I have a factor of x over x. And then I have a vertical asymptote, and that's going to be at +1, which means that I have x minus 1 as a factor. And then again, we can't forget that we need an a value as well. And then we're going to add that equation. Again, this is going to go down at the very end. That's kind of like our shift. I've got a plus x, and this will be our function. Just to reiterate, we have the x over x because of the hole. We have the x minus 1 because of the vertical asymptote. And then, again, I provided the line for our slant asymptote. We identified that it's just the equation y is equal to x. We're going to do the same thing we had done previously. We're going to identify a point, like this point right here, which is a point 2, 0. We're going to plug in our information for x and for y. So what we're going to get is 0 is equal to 2a over 2 times 2 minus 1, and then we just have plus 2 over here. I'm going to go ahead and subtract 2 on both sides. And we have 2 is equal to 2a over 2. The 2's are going to cancel conveniently, and we get just -2 is equal to a. We're going to go ahead and take that and plug it in for our a value, and then our function is going to be -2x over x times x minus 1, and then plus x. Okay, we are going to be skipping example number 4. You guys can just cross it off. And then I'm going to talk a little bit about the homework, and then that'll be it for our notes for today. Okay, so your homework is just the following page of the practice problems. We see them all here. For questions 1, 2, 3, and 4, you're trying to identify the equations of a rational function. We are going to be skipping completely question number 3, so just don't do it. And then if you look down below, we are reviewing the graphing of rational functions. Both question 5 and 6 review this, finding all of your asymptotes. If it doesn't exist, just put NA. If it does exist, find it and label it, and then try and graph it. And upload this along with your completed notes for your homework today. All right, that's it. Go ahead and get started, and good luck.